At the beginning of the 20th century, physics believed it had nearly explained the universe. The laws of motion were known. Gravity had been understood for centuries. Electricity and magnetism were being mastered. To many scientists, the universe looked almost complete. But then a young patent clerk, not a famous professor, not a respected academic, began asking questions that no one else was asking. Not in a laboratory, not in a university, but at a small desk in the Swiss patent office. His name was Albert Einstein, and he was about to do something that almost no one believed possible. He would challenge the very foundations of physics, not by building massive machines, not by conducting elaborate experiments, but by thinking deeply, relentlessly, and differently from anyone before him. Within a single year, Einstein would publish ideas that would completely transform our understanding of reality. Time itself would become flexible. Space would no longer be empty, and the universe would reveal a strange truth. That energy, mass, space, and time were not separate things, but parts of the same deeper structure. It sounded impossible, but it was true, and the quiet patent clerk who imagined it would become the most famous scientist in human history. But Einstein's story is not only about genius, it is also a story of rebellion, of doubt, of exile, and of a mind that refused to accept the limits of conventional thinking, because the universe Einstein revealed was far stranger than anyone had ever imagined. Albert Einstein was born in 1879 in the German city of Ulm. At first, nothing about his childhood suggested that he would one day reshape the understanding of the universe. In fact, many people around him believed the opposite. Einstein was a quiet child. He spoke slowly, and for several years he barely spoke at all. Some relatives even feared he might never develop normally. But behind that silence, something unusual was happening. Young Albert was deeply curious about the world, not in the way most children are curious, asking quick questions and then forgetting the answers. Einstein's curiosity was persistent. If something puzzled him, he would think about it for days, sometimes weeks. One moment from his childhood would later become almost legendary. When Albert was about 5 years old, his father showed him a simple object, a compass. The small needle inside always pointed in the same direction, no matter how the compass was turned. To most people, it was a trivial instrument, but to the young Einstein, it was astonishing. He realized that something invisible must be influencing the needle, something he could not see or touch. And yet it was clearly real. Years later, Einstein would say this moment was one of the first times he sensed that the universe contained hidden forces, waiting to be understood. School, however, did not go well. The German education system of the time was strict and highly disciplined. Teachers expected obedience and memorization. Einstein preferred questions, and questions were not always welcome. One teacher reportedly told him he would never achieve anything in life, but the teacher misunderstood something fundamental. Einstein was not slow. He simply refused to accept ideas without understanding them. And that habit, questioning what others accepted, would eventually allow him to see something no one else had seen before. Because sometimes the greatest breakthroughs begin with a simple decision to ask why. As Einstein grew older, his relationship with school became even more difficult. The German educational system valued discipline above everything. Students were expected to listen, to memorize, to repeat what teachers said without question. But Einstein's mind did not work that way. He wanted to understand why things were true. And when explanations were shallow, he became frustrated. Teachers often interpreted this attitude as arrogance or laziness. One instructor reportedly told him that his presence in the classroom was disruptive because his constant questions challenged authority. But Einstein was not trying to be rebellious. He simply could not accept ideas that did not make sense. To him, knowledge was not something to memorize. It was something to discover. Eventually, the rigid school environment became unbearable. At 16 years old, Einstein left Germany and moved to Switzerland. It was a turning point. In Switzerland, he encountered a very different atmosphere. Students were encouraged to think independently, debate ideas, explore mathematics and physics creatively. For the first time, Einstein felt intellectually free. He spent long hours discussing scientific problems with friends, not in formal lectures, but in cafes, small apartments, and late-night conversations. These discussions became laboratories of thought, because Einstein did not rely on expensive equipment or complex experiments. His most powerful tool was something much simpler: imagination. He would ask strange questions. What would it be like to ride on a beam of light? What would happen if you traveled through space at incredible speed? At the time, these questions seemed almost childish, but hidden inside them were ideas that would eventually transform physics. Because sometimes the path to discovery does not begin with equations. It begins with curiosity and the courage to follow it wherever it leads. By the beginning of the 20th century, Albert Einstein had completed his studies in physics, but the academic world did not welcome him. Despite his intelligence and strong understanding of theoretical science, Einstein struggled to find a university position. Many professors considered him unconventional, so instead of becoming a respected scientist, Einstein found work in a place few people would associate with revolutionary ideas: the Swiss Patent Office in the city of Bern. His job was simple: examine applications for new inventions, machines, electrical devices, and mechanical tools submitted by engineers hoping to protect their ideas. At first glance, it was an ordinary bureaucratic job, but the work had an unexpected advantage. Einstein finished his tasks quickly, and when the paperwork was done, he had something rare: time to think. Sitting at his desk, surrounded by stacks of documents, Einstein began exploring questions that had troubled physicists for decades. At the time, science believed the laws of the universe were almost fully understood. Newton's laws explained motion. Maxwell's equations explained electricity and magnetism. But something did not quite fit. Experiments suggested that the speed of light behaved in strange ways that seemed to contradict classical physics. Most scientists tried to adjust existing theories. Einstein chose a different path. Instead of adjusting the equations, he questioned the assumptions behind them. What if space and time themselves were not fixed? What if they could change depending on how objects moved? These were radical ideas. But in 1905, Einstein published a series of scientific papers that would soon become legendary. Historians would later call it his annus mirabilis, the miracle year. Within months, a young patent clerk had rewritten the foundations of physics, and the scientific world was about to realize that a quiet thinker in a small office had begun a revolution. The year 1905 would later become legendary in the history of science. At the time, however, it passed almost unnoticed. Albert Einstein was still an unknown patent clerk in Bern. He had no laboratory, no research team, no prestigious academic position. But within a few months, he would publish scientific papers that would completely transform physics. The first paper addressed a mystery that had puzzled scientists for years: the behavior of light. For centuries, light had been understood as a wave, but some experiments suggested that light sometimes behaved differently, almost like tiny particles. Einstein proposed a radical explanation. Light, he argued, was not only a wave, it also existed in discrete packets of energy, later called photons. This idea helped explain the photoelectric effect, a discovery that would eventually earn Einstein the Nobel Prize. But this was only the beginning. In another paper, Einstein explained the strange motion of tiny particles suspended in liquids, a phenomenon known as Brownian motion. His work provided strong evidence that atoms were real physical objects. Yet Einstein's most revolutionary idea came in a third paper. It introduced the concept that would forever change our understanding of reality: special relativity. According to Einstein, space and time were not fixed and absolute. They could change depending on motion, and from this new understanding emerged a simple equation that would become one of the most famous in human history. A short formula revealing a profound truth: mass and energy were different forms of the same reality. And with that insight, a quiet thinker in a small patent office had opened a door to a completely new universe. Einstein's ideas did not immediately make him famous. In fact, many scientists at first struggled to understand what he was saying. The theory of special relativity challenged one of the deepest assumptions in physics: that time flows the same for everyone everywhere. For centuries, time had been treated as something absolute, a universal clock that moved forward at the same pace throughout the entire universe. Einstein suggested something radically different. Time, he argued, was not universal. It depended on motion. If two observers were moving at different speeds, their clocks could tick at different rates. To most people, this sounded impossible. Time slowing down, time stretching. Yet the mathematics behind Einstein's theory was precise and elegant. And as scientists began testing his predictions, the evidence slowly accumulated. Experiments confirmed that moving clocks could indeed run more slowly. Particles traveling close to the speed of light behaved exactly as Einstein had predicted. Space and time were not separate structures. They formed a single framework: space-time. And motion through space affected motion through time. What had once seemed like an abstract theory began revealing something profound about the universe. Reality itself was more flexible than anyone had imagined. Time could stretch, distances could contract. The universe was not a rigid stage on which events unfolded. It was a dynamic structure constantly shaped by motion and energy. Einstein had not simply solved a scientific puzzle. He had changed the way humanity understood the nature of reality. As the scientific community began to understand Einstein's work, his reputation grew rapidly. Universities that had once ignored him now competed to offer him positions. Within a few years, the quiet patent clerk from Bern had become one of the most discussed scientists in Europe. But Einstein's greatest breakthrough was still ahead. In 1915, after nearly a decade of intense work, he completed a new and even more ambitious theory. It was called general relativity. While special relativity described how space and time behave when objects move at high speeds, general relativity attempted to explain something even more fundamental. For more than 2 centuries, gravity had been explained by Isaac Newton as an invisible force pulling objects toward one another. Einstein proposed something entirely different. Gravity, he argued, was not a force at all. Instead, massive objects like stars and planets actually bend the fabric of space-time. Imagine placing a heavy ball on a stretched sheet of fabric. The sheet curves around the weight. Smaller objects moving nearby naturally roll toward it. In Einstein's model, planets orbit stars for the same reason. They follow the curves created by massive bodies in the geometry of space-time. It was a bold and difficult idea. Many physicists initially doubted it, but in 1919, during a solar eclipse, astronomers measured how starlight bent as it passed near the sun. The results matched Einstein's predictions. Overnight, he became an international celebrity. Newspapers around the world announced that a new theory had overturned centuries of scientific understanding, and the once unknown patent clerk was now recognized as the most brilliant physicist of his generation. After the confirmation of general relativity in 1919, Albert Einstein became something rare for a scientist. A global celebrity, newspapers wrote about him constantly. Photographers followed him. His face, with the wild hair and thoughtful expression, became one of the most recognizable images in the world. But fame did not change Einstein's character. He remained deeply skeptical of authority and strongly committed to intellectual freedom. Einstein also spoke openly about politics and human rights, something many scientists of his time avoided. He was a pacifist. He opposed nationalism, and he believed that science should serve humanity, not destroy it. However, the world around him was becoming increasingly unstable. In the early 1930s, a new political force was rising in Germany, the Nazi regime. Because Einstein was Jewish and an outspoken critic of authoritarian politics, he quickly became a target. Nazi newspapers attacked him. His books were burned in public demonstrations. His scientific ideas were dismissed as Jewish physics. Einstein understood the danger immediately. In 1933, while traveling abroad, he made a difficult decision. He would never return to Germany. Instead, he accepted a position at the Institute for Advanced Study in Princeton, in the United States. It was the beginning of a new chapter in his life. America offered safety and intellectual freedom. But exile always carries a cost. Einstein had left behind his homeland, his colleagues, and much of the world in which he had built his career. From that moment forward, he would live as a citizen of the world, a scientist whose ideas had reshaped physics, but whose life had been shaped by the turbulent politics of the 20th century. During the 1930s and 1940s, the world was moving toward one of the most destructive conflicts in human history, the Second World War. For many scientists, this period raised a difficult question. Should scientific knowledge remain neutral, Or should it be used to influence the outcome of war? Einstein had always been a pacifist. He believed violence solved very little and often created greater problems. But in 1939, a frightening possibility emerged. Physicists discovered that nuclear reactions could release enormous amounts of energy powerful enough to create a new kind of weapon. And there was a growing fear that Nazi Germany might attempt to build such a weapon first. Several scientists approached Einstein with their concerns. Although he was not involved in building weapons himself, his reputation carried enormous influence. Together with other physicists, Einstein signed a letter addressed to the President of the United States, Franklin D. Roosevelt. The letter warned that nuclear weapons might soon become possible and urged the American government to take the threat seriously. This letter helped initiate what later became known as the Manhattan Project, the program that eventually developed the atomic bomb. Ironically, Einstein himself was not invited to work on the project. His political views and outspoken opinions made some officials cautious, but the consequences of the discovery weighed heavily on him. After the war, Einstein became one of the most vocal advocates for nuclear disarmament. He warned that humanity now possessed technology powerful enough to destroy itself. Science had revealed extraordinary truths about the universe, but it had also given humanity a responsibility that could no longer be ignored. Even after achieving worldwide fame, Albert Einstein never considered his work complete. While the public saw him as the scientist who had explained the universe, Einstein himself believed there was still much to understand. For the rest of his life, he continued searching for deeper principles that might unite the forces of nature. He dreamed of a unified theory, a single framework that could explain gravity, electricity, magnetism, and the fundamental structure of reality. Many younger physicists were moving in different directions, exploring the strange and emerging world of quantum mechanics. Quantum theory revealed a universe that behaved in unpredictable ways. Particles seemed to exist in multiple states at once. Events appeared to occur with probabilities rather than certainty. Einstein found this deeply unsettling. He believed that nature must ultimately be governed by consistent and understandable laws. Famously, he once expressed his discomfort with the strange implications of quantum theory by saying, "God does not play dice with the universe." Although Einstein never fully accepted the probabilistic nature of quantum mechanics, the debates he sparked helped shape the direction of modern physics. His questions forced other scientists to think more deeply about the meaning of reality. And even when he disagreed with new theories, his influence continued to guide scientific thought. Einstein remained curious, thoughtful, and intellectually restless until the very end of his life. Because for him, science was never just about answers. It was about the endless pursuit of understanding. Albert Einstein died in 1955 in Princeton, New Jersey. By that time, he had already become more than a scientist. He had become a symbol of human curiosity, intellectual courage, and the power of imagination. Einstein had shown that the universe was far stranger than anyone had previously believed. Time could slow down, space could bend, energy and matter were deeply connected. Ideas that once seemed impossible had become fundamental principles of modern physics. Yet Einstein's greatest influence was not only scientific, he changed the way people thought about knowledge itself. Einstein believed that creativity and imagination were essential to discovery. He once said, imagination is more important than knowledge." because knowledge describes what we already understand. Imagination allows us to explore what has not yet been discovered. This philosophy shaped the way generations of scientists approached their work. Today, technologies that define the modern world, from GPS satellites to advanced particle physics, rely on principles that trace back to Einstein's theories. But perhaps his most important lesson was simpler. Einstein showed that revolutionary ideas do not always come from powerful institutions or large laboratories. Sometimes they begin in quiet places, at a desk, with a curious mind asking a question others overlooked, and the courage to imagine that the universe might be different from what everyone believed. More than a century has passed since Albert Einstein first introduced his revolutionary ideas, and yet the universe he revealed continues to shape modern science. His theories are no longer abstract concepts discussed only in classrooms. They are tested every day. Satellites that guide airplanes and smartphones must account for relativity, because time in orbit flows slightly differently than it does on Earth. Astronomers observe distant galaxies whose light has traveled across the curved fabric of space-time, and physicists continue searching for the deeper structure of reality that Einstein spent the last years of his life trying to uncover. But Einstein's legacy goes beyond equations and theories. He changed the image of what a scientist could be. Not a distant authority, not a rigid academic, but a curious thinker willing to challenge assumptions and imagine new possibilities. Einstein once wrote that the most beautiful thing we can experience is mystery, because mystery invites exploration, and exploration drives discovery. The universe remains vast, complex, and filled with unanswered questions. But thanks to the work of one persistent mind, humanity now sees it with greater clarity. And the quiet patent clerk who once wondered what it would be like to ride a beam of light helped reveal the deeper structure of the cosmos itself. And perhaps that is the greatest lesson Einstein left behind. The universe is not only something to observe, it is something to question, because every great discovery begins the same way, with someone looking at reality and daring to ask, what if we are wrong?